Welcome everyone, I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 2064, which is minimized maximum of products distributed to any store. Let's see the problem statement. You are given an integer n indicating there are n specialty retail stores. There are m product types of varying amounts, which are given as a zero index integer array quantities, where quantities I represent the number of products of the ith product type. You need to distribute all products to the retail stores following these rules. A store can only be given at most one product type, but can be given any amount of it. After distribution, each stores will have been given some number of products, possibly zero. Let's X represent the maximum number of products given to any store. You want X to be as small as possible. That is, you want to minimize the maximum number of products that are given to any store. Return the minimum possible X value. So this is one example. Let's say there are 6 stores and the quantities are 11 and 6. So we have to give all this amount to these stores. Means we have to this amount is sum of this amount is 17. We have to give 17 quantities, but we have to follow these two rules. Means we can't give one retail store to different type of product. Okay. So 11 can be divided into 333. That means we can give 4 retail store this product of type this 0 element, and the 6 will be divided 3 and 3. So in total we can give 6 retail stores the 17 amount, and this is the optimized solution, and the maximum value any retail store get is 3, so the answer is 3. And in some cases the some retail store can also get 0, like 0 means 0 quantity of any amount, because it could also possible, like, because in the second case. Okay, now let's see the constraints. The n and m will be up to 10 to the power 5, and the value of m, which is the length of quantities, will always be less than n, and the each element present in quantities will be up to 10 to the power 5. So let me discuss the algorithm with you, how we can solve this problem. So first, we need to understand what could be the possible value of x. The possible value of x could be from 1 to up to the value max value present in quantities. Means the value which is maximum in all values present in quantities. That could be the value of x, because then because maximum means if we give the maximum value to each of the like retail stores, then we can give maximum of like m retail store, and m will always be less than n, so some retail store will get a 0 value, so that is not a problem, but we need to optimize it. And every time we need to we will use binary search to find the value of x. We can't go like from 1 to m. Each time we have to use binary search to find the value, and each time we need to check whether we can possibly give all the values, like in this case this is the sum of the values we can give to all the stores. In all the stores, is it possible to give, like if the value of x is, let's say, 5, then can we give all the product possible amounts to each of the stores without each of the retail store is exceeding the value of x. Means we have to give any amount that is not greater than the value of x in each binary search. So let's start. So first I am creating one function, like this function will check that we can is it possible to give all retail store in like an amount. The max amount will be, let's say, k. So let's say possible, int n will be the retail, the number of retail stores, like k is the maximum amount that we can give in to a retail store, and vector int q is quantities. So let's start with initially current value is 0. Current means currently how many retail stores are given some at least some quantity. Okay, for auto IT in quantities, for each of the quantity, first we need to divide the like value with k, and to get the number of retail store we are distributing this amount. So let's say temp is equal to IT divided by k, and if IT mod k present means after dividing with k by k, if there is some reminder, that means we need to add one another like we need one another store to distribute the remaining amount. So the temp will be plus plus. Now current will be plus equal to temp, and we need to check if the current is not exceeding the n, because the current value is number of retail stores we are currently distributed and it should not be greater than n. So if current is greater than n, then it return false, because we can't give n retail stores, it is exceeding the value, and after that return true. That's it. And here first we need to find the maximum value, because we will use the binary search from 1 to the maximum value present in quantity. To check the maximum value, to get the maximum value, either you can use for loop, traverse one time, or I am using inbuilt function. Let's say mx is equal to star max element. This will also work the same way, and let's say quantity as q, because I can't write quantities each time. So q dot begin to q dot end. Now this max function is contains the maximum value present in quantities, and our minimum value is 1. Now let's say answer is initially 0, and while for binary search we need to check if while mx is greater or equal to mn. Now first we need to find the midpoint, so md is equal to minimum plus max minus min divided by 2, and if possible of possible is taking n k, n k is the current md and q is q. It, if it is possible to give all like all the products or the values present in q to n retail store, and some retail store can also get a zero value. Is it possible? If it is possible, that means we need to reduce the number. To reduce the number, we will use like we will bring the mx equal to mid minus 1, and our answer will be current value is possibly current value is media md, so it is answer will be md. And else if it is not possible, that means we need to increase the amount. So to increase amount, we will bring the mn is md fixed one. That's it. After that we need to return the answer. Now let's see will it work or not. It is accepted. Let's submit it. So it is accepted. Let me discuss the time and space complexities with you. So this max element, to find the max element present in Q, it is taking big of log big of m time, where m is the length of Q, and this while loop is running like big of log v time, where v is the max element, and this possibly function is taking big of log big of m time, where m is the length of Q, because we have to find for each of the element. And this overall time complexity for this while loop is big of m log v time, where m is the length of q and v is the max element present in q. And this is also taking big of m time. So overall time complexity is equal of m log v. And space complexity, we are not creating any array or list which is depending on the length of queue. We are just creating some variables. So the overall space complexity will be big of constant, or you can say big of 1. So thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.